Hey guys, this is just a quick feedback for this assignment, homework 12.1 through 12.2. So I'm grading 3 of these, and sometimes when I grade the problems, I'll give you little comments when I return the grade to you and say like, hey, you got this one wrong because of this. In this assignment, I think it will be easier to just make a quick video that I can give you a link to. So if you get a problem wrong, I can just say, hey, go check out this video to see what you did wrong. So when I grade an assignment, it's worth 10 points. You're going to get 7 for doing all the problems, just like a completion grade. But 3 of them I want to grade because I want to give you feedback on how you did so that you can learn from your mistakes. Since we're not like talking to each other, you know, in real time, you're not in a class, I can't like really keep an eye on you to see how you're doing. So this is just a way for me to provide feedback and let you know how you're doing. Okay, so there's 3 problems that I'm going to grade from this assignment. I'm going to do them real quick for you. If you got one of them wrong, you can kind of jump to the one that you got wrong and figure out why. Okay, so one of the important ideas that we did is we proved this triangle sum theorem. Okay, which means the angles of a triangle all add up to 180 degrees. Okay, so we're going to use that in this, and I did a couple examples from this, or I did at least one example for you from this section. So let's take a look at 12. This is one of the ones I'm grading. So what we know, the triangle sum theorem says, back it up here, the sum of the measures of the interior angles of a triangle is 180. So that's what we're using. So in number 12, all these angles have to add up to 180. Okay, so we got 5x plus 12x plus 5 plus this guy, which we know is 90 because of the way it's labeled. Okay, so all those guys add up to 180. Now, you could actually, well, actually, let's do one step really quick, and then I'll come back and show you something. If you wanted to, you could actually just say this plus this equals 90. The reason why is if you know this is 90, then the rest of the angles have to add up to 90, right? So that's a shortcut, but you don't have to do it that way. Either way, we're going to get there. So 5x and 12x together is going to be 17x, and then we have plus 95 equals 180. Okay, so just combining like terms, we're going to minus 95 from both sides. So 17x is equal to, it's going to be 85. Okay, and then we're just going to divide both sides by 17, sorry. So let me grab my calculator. Hey Siri, what is 85 divided by 17?
It's 5.
Awesome! Okay, so x equals 5. And that's what we were looking for, right? We're looking for x. Oh, no, sorry, find that measure of x and then use x to find the measure of a. Okay, cool, so we do need one more step. So we know x is 5, right? We plug it back in. 5 times 5 is going to be 25. So the measure of angle A equals 25 degrees, right? So solve for x first, then plug it back in because we're really trying to find the measure of angle A. Shoot, I cut that off. Okay, there's the rest of it, sorry about that. So combine like terms. Subtract 95 from both sides, divide both sides by 17, x is 5, plug back in, 5 times 5 is 25. Measure of angle A is 25. Okay, so that's using the triangle sum theorem. Okay, let's look at one from the next page. So the next proof that we talked about is this guy, the exterior angles theorem, and this is that the exterior angle of a triangle, like this guy number 1, is equal to the sum of the 2 non-adjacent interior, these 2 guys. Okay, so let's take a look at 17. Make sure I get the whole thing in there this time. Okay, so here's an exterior angle. These are 2 interior angles that are non-adjacent, right? This one and this one are adjacent. So this is an interior angle that is adjacent to this exterior angle. What we want is we want the 2 interior angles that are non-adjacent. Okay, so the exterior angle theorem says that the exterior angle is equal to the sum of the 2 non-adjacent interior angles. So that's our setup. Okay, all we got to do is solve for x. And in this case, the directions just say solve for x. We don't have to plug anything back in. So 140 equals 22x, when we combine like terms here, plus 8. Okay, so we're going to subtract 8 from both sides. We get 132 equals 22x. Let's ask Siri what that is. Hey Siri, what's 132 divided by 22?
The answer is 6.
Hot dog. Okay, so 6 equals x. And then we'll use our symmetric property of equality to flip that around. X equals 6. Okay, that's number 17, using the exterior angle theorem. Okay, all right, the next one that I graded was 23. So 23, we're trying to write a congruent statement. Now there's actually multiple ways to write this. There's like 6 different ways you can write this congruent statement. So the main key though is to figure out what the corresponding vertices are, because they have to be in the same order. So let's take it one piece at a time. Let's start with this guy R. Now we're looking at this as a vertex, not an angle. But so the vertex R, notice that the angle that's off of R here, which we would call like BRC or something like that, it has this one, arc, and this one has this one arc. So this point R, this vertex R, it actually corresponds to itself. So R corresponds to R. Okay. Then let's look at the one with 2 markings. So C, the angle C has 2 markings on it. And then this angle S has 2 markings. So angle C corresponds to angle S, which means that the vertex C corresponds to vertex S. Now the reason why I didn't say angle R is because you can't call this angle R, because there's 2 angles that use this as a vertex. So you'd have to be more specific and say CRB or BRC or something like that, and then SRT or TRS to describe these 2 angles. C and S are fine because they're only one angle using that vertex. So sometimes we refer to them, as this vertex R corresponds to vertex R. But you wouldn't say that angle R corresponds to angle R, because you wouldn't call this angle R and you wouldn't call this angle R. In this case, you can do that though. Okay, and then B. So vertex B or angle B. Angle B is named after vertex B, it has 3 markings, and angle T, which is named after vertex T, has 3 markings. So B corresponds to T. Okay, so when you write your congruent statement, the most important thing is that you put the corresponding pieces in the same position. Okay, so let's name this triangle here. Let's call it triangle BCR. Okay, now you don't have to write them in that order. You could call it CRB or RCB or whatever, it doesn't matter. But as soon as you have that ordering, the ordering of the next one does matter. So once you set it down, B has to be in the first position, so that its corresponding vertex, T, has to also be in the first position. Okay, this, when you read the statement, the position of the letters tells you which corresponds to which. Okay. So the next one was C, right? And C corresponds to S. So since C is in the second position in this one, S has to be in the second position of this one because C corresponds to S. And then of course we have R, so R corresponds to R. Okay, so this is one way to write that congruent statement. It's not the only way. You can rearrange these letters however you want, as long as when you do that, the order of these letters matches its corresponding vertex. So let's write it at least one other way just so you can see that. Okay, let's write this triangle as RCB. Okay, so triangle RCB is congruent too. So this triangle RCB and this triangle BCR, they're referring to the same triangle, okay? But if we're talking about a congruent statement, the second triangle that we write when it's congruent to the first has to have the corresponding vertices in the same order, right? So R corresponds to R. C is in the second position and C corresponds to S. So in this second one, S has to be in the second position. And then the last one, of course, is B, which corresponds to T. Okay. So T has to be in the third position. So this is another way you can write it. There's actually 6 different ways you can write this statement, but what I'm checking for, what I'm looking for, is that the corresponding vertices are in the same position. Okay. All right, hope that helps. If you got one of those wrong, hopefully that helps clarify, and now you know and you've kind of learned from your mistake. And yeah, you know for the future, for next year, and for the final. Thanks for watching.